Hello, everyone. Super happy to be here. Last time I was here, it was to talk about a castle in the town of Eve. And now we're talking about the state problem. So where have we been? Where have we been? So I'm the founder and CEO of Comef. You maybe heard of us. I'm also teaching here and there, and I'm indeed the president of Ethereum France. I hope to see you all at ECC in July. It's going to be a bash. Hopefully see you at ECC. So before we start to deep dive, I want to give you the angle that we have when we talk about this problem. At Comef, we are a gaming company. We do games. We've been doing on-chain games. We've been doing less on-chain games, and recently we started a game on Epic Game Store, distributed there. And we do also the tech stack for those games to work. So we distribute middlewares for retail application, and notably we work with Gnosis on Metri. So while we were trying to onboard people into games, when we were trying to onboard non-Web3 minded people into retail blockchain application, we were faced with a huge customer acquisition problem. Because you need to install a wallet, because you need backup, because you need to buy crypto, because you need crypto to use on the chain, and so on. And for us, it was just a nightmare. The conversion funnel was just so bad. It was in the year of 2021 and 2022, so we didn't have as many fancy techniques as we do right now to onboard. And for our latest game, we moved to full account abstraction that we distribute and package on top of Safe, and also on our own layer 3 on top of Arbitrum, so we have the capacity to properly sponsor transaction for the user. Now, here's what we think is going to be the low-hanging fruit in terms of user acquisition. Here's Bob. So Bob has ETH on a centralized exchange. So he's already crypto interested, crypto minded. It's easier to convert those people than it is to convert someone that has heard about Bitcoin but think it's for terrorism and money laundering. And it's also easier to convert those people than just say like, hey, it's cool, it's on the blockchain, you should check it out. So typically, when you have a full account abstraction application, the user don't really see their account at first. They just get onboarded as they would on any Web2 application. And when they start to dig in, they realize that they have a wallet, and they may be willing to withdraw some money on this account and start to use this account elsewhere or in another way. So we have many Bobs already in our games, like people that have onboarded on our game, that have tried to do transactions that were sponsored, didn't really realize what was happening, started to put their own wallet to grow the number of owners of the safe, for example. And at some point, many of them decide to withdraw from their centralized exchange to their safe that we deployed for them. And thus they rush on the Discord asking like, where's my money? I don't know. Where's my balance was updated and so on. And then we get into, from what we perceive is a pretty big state problem. Like the state of the different EVMs that we have deployed are not properly shared together. And as of today, we are entering a change of paradigm. I mean, you've seen this at this conference. Umbuyer, Metri, Monerium, Clave, Gnosis Pay, and so on. We start to have a lot of very good way to onboard people. So we are likely going to get a lot of Bobs, and this problem is going to get bigger and bigger. Thankfully, the best minds in our ecosystem are thinking hard on this problem, and so like Vitalik and other people are posting a lot of research stuff about this problem, like making sure that we have eventually a minimum key store rollup where we store everything that's happening in the account and we replicate the state of the account this way between different chains, trying to suggest things that we should do in order to improve the situation because the problem is about to grow a lot. Coming back from when we started Ethereum, when we were using Ethereum and installing a node, the first thing you were supposed to do is go on the Ethereum browser called Mist. Once you were running an Ethereum node, you had Mist installed on your machine. And Mist was connected to your node, and you were browsing the Web 3.0 through Mist. And every time you had a request for something blockchain related, then Mist will just talk to your node, and you will access the blockchain data this way. Unfortunately, it was a bit too hard to push people to all install a node in order to access the blockchain. We started to have wallets like MetaMask, like others, that were exposing remote procedure call, RPC towards nodes like Infura and so on. And then we started to lose a bit this strong connection to the chain, like putting everything that's available on chain directly on the computer of the user. Well, then we started to switch about how we are going to scale the network. And the first attempt of scaling Ethereum was to use the beacon chain as a coordination layer, as a coordination layer between different shards where things were going to be executed and everything would be reconciled towards the beacon chain. So beacon chain as a coordination layer has the tough problem of how do we make sure that there is cross-shard communication. And in the years 2018, 2019, early 2020 a little bit, everybody was thinking about that. Like, how do we do good cross-chain communication problem? The main problem was shaped as the hotel train problem. Like, if there is a hotel on this shard and a train on that shard, how do I make sure I do one single reservation, one single booking to access my train and tickets? So all the techniques that we started to shape at this stage were asynchronous or synchronous, and they translated themselves into different attempts at doing good bridges between chains. The number of bridges hack, the cost of using bridges, and the maturity of those bridges highlights how much we need to work a little bit more on those problems. And today we have this roll-up scaling strategy, which has been very successful into giving us a lot of EVM block space to fill. So we switched to having Ethereum as a beacon chain connecting all the shards and making sure that the communication is good between those shards into several layers of layer one, several stages of layer one. So you have the execution layer, like where we actually run the transaction, the mainnet, the EVM on the mainnet. And we have the consensus layer, a way to get the consensus on proof of stake of what is the stage of the layer one, but also to gather some data, like the blobs from the EIP 4844. The data can be a bit misleading because this data is not supposed to be permanent. It's supposed to be there for a while just to guarantee some security aspect. And then all the rollups, all the L2s and L3s and so on, can communicate with the layer one and benefit from the blobs and the consensus layer and the execution layer to continue acting and providing security to the user. But it feels like we kind of forget that we need good cross-layer communication. So a big lingering question for me is, are we going to get enough block space to dilute this problem into more gas spending? And as of today, we have a few researchers, notably Ankit and Stefan from Frontier Research, that are trying to shape this problem in the rollup context, in the multiple EVM context, without any good coordination layer. So they came out with the Cake framework for chain abstraction key elements that highlights the different components that you do need to realize a good cross-chain abstraction, a good chain abstraction, to have good abstraction of the chain you are in for a user. When as a user you browse a website, you're not asking yourself, is this website on AWS? Are they using GCP? I'm not sure. I need money on GCP to use it. Yes, indeed. And the end game would be, of course, that my wallet, j.tychey.eth, is showing me the balance that I have on all the networks together all at once. Like eventually with a weighted fashion, say like, oh yeah, but you need to pay X to get out of this and get there, but this is what you have in your wallet in the first place. So in order to get there, I tried to look at those different components. Of course, you don't need all the components to realize a good solution. There's mixes that can be done. But looking at the different companies that were building on those different components and trying to say, like, well, they only have a landing page, no code is public, the documentation is out there, oh yeah, they're live on this network, on that network. I tried to gauge how much we were mature on the topic. So that's my personal view on this. Maybe I missed a lot of people that were trying to build in this space, but we still have a lot of work to do to make it workable from my perspective. And also, if you want to do chain abstraction as a whole, you need to be supporting a lot of chains. So it means that your infrastructure needs to be super scalable as well. So yeah, adding problems on top of the problems. A couple of highlights though. At this conference, there were a talk about ASHI, which is the cross-chain alliance that's going to look at this problem and try to bring solution or bring together different initiatives towards this solution. And also the work that we did in R&D at ComF called Storyless, which is storage proofs, like proving that something is included in an EVM, and trying to figure out how we index that and distribute that at a large space. We will do some updates on that at ECC, very likely, and if you want to check it out, the code is also there. And as a conclusion, we still have 10 minutes, that's great. I wanted to give an opportunity for Stefan to get a deeper dive on One Balance, which is an initiative that builds on top of the Cake framework to realize what we think is going to be the next big thing in terms of account abstraction and chain abstraction. So please, Stéphane.
Amazing. Thank you so much, Jérôme, and so kind of you to give up some of your time. I know you have to run to the airport soon, and so I really appreciate it. Big shout out to him. I mean, what a legend in the space, and so yeah, feeling blessed for the opportunity. Okay, let's talk a little bit about one balance. Leveraging a bit of what he's talking about with the cake framework. First, we can talk about why we care about chain abstraction at all. And so I think everyone realizes that the best time they've had on Ethereum so far was a few years ago, when it was easy to farm vegetable coins and it was like one-click experiences, but it also was really expensive to do so. And so we spent the better part of the last 4 years trying to figure out how do we actually make it so it doesn't cost $1 million just to do a transaction. And we've managed to achieve it, but now we're in this world where we have fragmentation across the entire ecosystem, and I've found it extremely difficult to use the chain, and I'm sure I'm not the only one. And so unless you're really motivated, and in many cases financially motivated to do so, it makes very little sense for users to go figure out this mess. And so how do we actually get to the dream world that we want to be in, where we actually have both the usability and the scalability? That's sort of the problem that chain abstraction is trying to solve for. And so we proposed this framework called the cake framework. And the entire thesis behind this is, if we solve the cake framework, we get to the world that we want to be in. The other part of it is, we believe each one of these components, we stand on the shoulders of giants, and there's a ton of money that's been spent trying to solve these issues. The main issue is that these people aren't really talking to each other, and they're integrating sort of common interface to be able to achieve the UX improvement. And so that's what the fragmentation comes from. It's not just about like technical fragmentation, it's like social language of the developer community not talking to each other fragmentation. So that's what we're looking to solve with this working group. So we just have a bunch of different folks here, and these are all sort of middleware sort of layer folks. And then we're launching a new work stream for wallets and apps. And so anyone that's working more towards the UX of solving these problems, we have a new group for this. So that's my cake plug. And then I would love to talk a little bit about one balance and what I call the fat account thesis. So I think we've been in this sort of view of the world since 2016, more or less, that focuses on the idea that the chains and the L1s is where the majority of the value accrues. And if you look at sort of the top 100 coins on CoinGecko, the majority of them are sort of L1 protocols, right? But there isn't really anything that sort of backs this meme. And as far as I can tell, this is sort of the source of it. So the idea for fat protocols is saying, oh, actually all the network effects accrue to the base layer where the smart contracts are actually operating. My claim is that this is actually an outdated view of the world. And this is based off of a perceived scarcity of block space, which we no longer have. And in a post-abundance of block space world, what we actually go towards is what I call the fat account thesis. So the chain-centric view says, okay, we have credible commitment machines and global consensus that are bundled together. And because you're bundling global consensus, it's really slow and expensive to do, and so therefore it's going to accumulate a lot of value and it's going to have network effects. What I'm proposing is, now that we're in a post-block space scarcity world, actually what we're bundling together is the account and the credible commitment machine, and we're taking out the global consensus. And this completely shifts the ecosystem from focusing on chains to focusing on accounts. And my claim is this transition is both inevitable and necessary if we want to solve all of the UX problems that the fragmented space has today. So, what is our contribution to this? Our contribution is looking at the equivocation and global consensus dilemma. So equivocation comes from sort of the way that EOA accounts are designed today. So EOA accounts are public-private key pairs, and they sit outside of the chain. And so the chain has no view over what the account has or hasn't signed. As far as the chain knows, any request that is a valid signature over a given nonce needs to be processed in compliance with the consensus of the protocol. And so at any time, a user is able to equivocate their request by simply overriding their nonce. And so this nonce overriding is possible because the chain doesn't have this view. The problem is, if you're relying on an architecture, like in the cake framework, where a counterparty brings the transaction to the chain on behalf of a user, if the user is able to equivocate, they can essentially grief the solver. And this issue becomes even bigger in a cross-chain setting where you have asynchrony. Because if the user issues a request over here on chain A, and then the solver does something over here on chain B, they can't rely on the atomicity of execution between these two things to provide safety over their request. And so they can't revert if the user double spends on chain A. The class of solution for this is sort of widely known as HTLCs. It sort of says, okay, well, we actually need to lock the user state on the origin chain for a period of time to allow time for asynchronous execution to happen on the other network. So this is where we go into sort of the next evolution after EOAs, which is the concept of smart contract accounts. And so one solution to this equivocation problem is to say, let's just put the account on chain. Now the chain has a view over everything that the account signs, and so the chain is able to say, oh, this account has locked this state for this period of time. It's credible because that state is locked on chain, and it's within the rules of the global consensus. The problem with this is global consensus is really expensive. And so we enter into this thing called the account dilemma, where on one side you have EOAs, which are fast and cheap, and you can issue a bunch of different signatures basically at the speed of signing, but you allow the user to equivocate at any time. And then on the other side, you have smart contract accounts, which can't equivocate because they're part of a credible commitment machine, but they're really slow and expensive because of global consensus. And so the dream world that we need to be able to achieve chain abstraction is top right corner, 2-2. And I'm going to present sort of what I think we need to get there. So that's what one balance is trying to resolve, is this dilemma. The way that we do so is by introducing the concept of a credible account. So credible account is sort of a successor to smart contract account. And it says, actually, instead of hosting accounts directly on a chain with global consensus, accounts can be hosted on any credible commitment machine that's mutually agreeable between the user and the solver. That's a key point. We'll get more into that. And then the other piece I introduces is the idea of a resource lock. So a resource lock is like a really scaled down version of call data that actually doesn't specify anything about the execution trace or the execution semantic on the destination chain. It only specifies the inputs and the outputs of a specific state transition. And it lets the solver figure out the rest. So these locks are these like credible commitments. So they're escrows that are issued within the account that solvers can rely on for the period of time that this escrow is in practice. So this is an HTLC at the account level. And then credible accounts. So credible accounts are, again, just accounts that are hosted on a credible commitment machine, which allow for the fast and cheap fulfillment. One way to think about this is take smart contract wallets and put them such that each smart contract wallet is its own rollup that's able to deposit state from an arbitrary number of chains. And it's able to process transactions really, really quickly because it has its own sequencer, and it doesn't have any dependencies on anything outside, but it's able to trigger state transition functions on any other domain. That's essentially the world that I'm proposing we head towards. There's many different ways to get there. So we explored in our post 4 different architectures that we believe sort of achieve this outcome. I call them like the 4 architectures for credible accounts. One of them is using trusted execution environments like SGX. Another one is by using an MPC and doing threshold signatures over sort of a consensus of nodes. Another one is putting this sort of smart contract accounts on a roll-up approach. And finally, some of the more recent discussion is around the use of VM modifications directly, like 7702. So all of these try to achieve sort of the same thing, and they all come with different trade-offs. I expect that the optimal implementation of this is going to evolve over the course of the next few years as as we make the transition towards this account-centric worldview. I posit that this new worldview is necessary and inevitable. And what we're building is a framework for being able to manage these types of accounts on a bunch of different architectures. And so we consider every part of the cake stack sort of a module or a plugin that fits into these new types of credible accounts. So yeah, there's a link here if you want to learn more about it. And again, thank you so much, Jérôme, for the stage space. Appreciate it.
You want to take questions?
Oh yeah? Okay.
All right. Does anyone have any questions? Yes.
Hi, thanks for this presentation. But I'm wondering how to create a smooth transition to new proposed accounts, because currently we have a huge problem with legacy. For example, we have a ERC20 standard, then maker token doesn't support name or symbol in string value, it returns byte 32. And all time when new innovations come, we create like a EVM versioning when one EVM version doesn't support PASH0 opcode or T-store opcode and so on. And when the new accounts could come, how the current code base, for example, Uniswap or Aave or any other big protocols could support these new accounts to make it seamless transaction to users without not rebuilding the whole code base of really well battle-tested protocols.
Yeah, I have an answer, but I mean, you've seen this firsthand with the transition to smart contract.
Yeah,
accounts, right?
there's many discussion happening right now on how we make people transition from EOA to smart accounts. It's completely opt-in. You don't know, you're not technically supposed to be forced to be transitioning to any smart accounts. But there is a lot of very good arguments that this should be the case, and this should be at some point the default as well, notably with rolling out different keys and being able to change your keys and so on. There was an initiative that got replaced recently by another one, the EIP 3074, that was supposed to be included in the next fork, that will be replaced with another EIP that's more aiming towards a smart account as a transition. So at the EVM core level, we are introducing ways for people to migrate easily from their EOAs to smart accounts. And what we'll be doing is like, oh, I'm taking my MetaMask and I'm now declaring that this MetaMask is now invoked by this new smart account. The good thing for existing smart accounts, smart contracts like Uniswap and blah, 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 is that from a smart contract perspective, talking to a smart account that has been transitioned from a EOA will be the same. The transaction origin will be the same. You'll be invoking from this account. And so there's no change to be done while we do this transition. And this transition is already happening and already like in target.
Yeah, so I think it touches really well on the smart contract account sort of transition. My claim is maybe a little bit more meta, which is I see current EOAs as an inadequate equilibrium, if you're familiar with that concept. And like a lot of standards are poorly designed are. They're kind of these things that everyone uses because everyone else uses, but they would rather be using something else. And there's like clearly something else that's better. And so I see my job in the Ethereum ecosystem or the crypto ecosystem as a whole to like help the community switch from one inadequate equilibria to like a better one. And that's a coordination problem. Like any standard is a coordination problem, any blockchain technology is a coordination problem. And so when you ask this question, what I hear is, how do we solve the coordination problem, getting people to switch over from an inadequate equilibrium to a proper one? It takes a lot of like presenting things, getting people excited about it, and all this stuff. But fundamentally, people only shift when they have an incentive to do so. And so I believe that this is inevitable because the capabilities that it delivers for end users is so much better that the applications that integrate this first are going to have a huge advantage over current applications. Like this is over a 10x improvement over the current state of things with EOAs. And so it's inevitable that people will innovate and start to adopt this, and then eventually the bigger folks that are slower to move are also going to change. Practically, what needs to happen is we need to switch away from this JSON RPC API that was designed in like 2014 to manage EOAs on Ethereum nodes towards an RPC API that's actually designed for wallets. And there's a bunch of different proposals, and so we're working with folks like Wallet Connect to get these new methods that are much more modern deployed within all of these different wallets and apps.
Yeah, smart accounts at scale are cheaper for the network.
Yes.
Yes.
Anything else?
I think we're out of time.
Okay.
Anyway,
Thank you for the question.
let's chat if you want to deep dive more.